Hello all. Okay, in this video I'm going to take apart an old stereo. It's a small one, a small portable stereo. I got it from a friend of mine. They were going to be throwing it out. It sat in storage for ages and they were clearing stuff out and they remembered that I do videos of taking things apart. So in this video I'm going to take it apart. So first thing I'll do is I'll turn the camera around and show you the model of it. So I've never had any dealings, I've never heard this thing working before that I could recall. If I did, it would have been a long time ago. Technika, digital, ultra high power, high fidelity system, so it's a hi-fi. As I say, it's a very small, very small. It's not a very big thing at all, but before it goes into skip, I'm going to take it apart. A few pictures of it. I'll show you what it looks like before I dismantle it all. It came with a stand as well. Show you that. So from what I figure anyway, I've never used it before, I think that's how the stand goes in. It kind of would have went in like such. And it would have sat like that, I would presume. So we'll get a few pictures of it before it'll be the last I'll see it in this condition. So that's what it would be. I don't even know how old it is. I think they said it was, maybe 2005 or something they bought it, which means it's about 20-year-old, and it's probably been stored for a good 5 year anyway, 5 to 10 years. I don't think it's working. I think that's the reason why they just replaced it with something better. I'm not even sure how this thing opens actually, to be honest. One thing for sure is I'll get it broken open. I'll get it open alright, don't worry about that. It'll be in bits, but it's supposed to open. It might need power. See, it would need power to get it open. Officially that is. But I've got my toolbox and hammer, and pry it open. I've got my helpful toolbox with means of getting it open. So I'm no technician or anything like that, I'm not an electrician, but Dad is. He would be able to explain a lot about the inner workings of it. What I'm going to do in my video, because it's my video, I've just got to give you my understanding of it. I'll just explain how I'll just tell you what I think the parts are that are inside it and how it works, and I'll just give you my explanation of it. This video is only solely for entertainment purposes only. It's not to be used as a quotation as to this is how it works, so don't quote me. It's only just a video for entertainment purposes, showing you me disassembling this stereo to show you what the parts look like inside, and at the same time inbuild my knowledge as well whilst I do that, and I'd just like to share that with you. Most important of all, you never open this thing up when it's plugged in and switched on. The plug's off, it's been off for ages. A qualified electrician would know exactly what they're doing, but if you don't know what you're doing, just don't take electrical appliances apart, because it could be deadly voltages inside them. You've got capacitors in there as well that store charge in certain items. I don't know about this one, but there are things like microwave ovens. I've took one of those apart and that has a large capacitor inside it. I've done a video on it as well, way back on my channel, if you want to see that. But first things first, I'm going to get the screwdriver out and get the back off this thing. So in order to get it apart, it looks as though there's Phillips screws going right round the peripheral of it. So it's quite a funny size. It's actually quite small for the size of head. The Phillips bit, the cross bit, is quite small for this size. But this screwdriver seems to, it's because it's quite a sharp screwdriver, it seems to do the trick. So I'm just simply going to go around all of those. Now, it's quicker and easier if I just do this using my both hands. So I'm going to have to put the camera down for this point, but I think you get the idea what I'm doing. I'll just show you what one of the screws look like. so they're quite small as well. So I'm just going to go around and get all them off. So I've got all the screws out. I'm going to remove the back in a minute. I'm just noticing that these there will be used for a means of hooking this up to the wall or something, like wall mounts. I'm guessing that's what they were. And being portable, it's also battery operated, which still has batteries in them, surprisingly. They were flat as a pancake though. I'm quite sure they were. I'll just put them that way. Press it on. Yeah, so that's batteries wouldn't even matter. Look at that. It's got a mains plug on it as well. So I'll get these batteries out. Be careful they're not leaking, because they might have been in there for quite a considerable time. In fact, I think they are leaking, because there's some sort of they're alkali batteries. It's not a very good idea to be touching that. I've got my cloth here anyway. Chuck them in this old bag for now, and I'll be disposing of all this stuff responsibly when I'm finished with it. So there is one screw left. Now, I'm not quite sure what that one is all about, but I'm going to remove it anyway. In fact, there might even be some more. Gosh, there's even more. Grief. So there's some more Phillips screws down here as well that I'm going to have to tackle. Shouldn't be too difficult, but so I'll get them out anyway, one way or another. I'll just turn the thing on its back and shake them out. I'm slacking them off. They're certainly held in with plenty of enough screws anyway. See, that's it out, but it's not a magnetic screwdriver, or the magnetic. Maybe the screwdriver is, but the screws aren't magnetic, or vice versa, or both. Anyway, I'll put this down for now and I'll get them out. As I was trying to shake this CD player apart, the speaker covers came off, which shows the speaker behind it. I just sort of push fit on the pegs, just these pegs there, just push into the holes. So it's a CD player, there would have been a laser, a warning for the laser. Now, the screws, I've slackened them off, but they're kind of like still, you know, coming out of here. I'll have to shake it loose, shake the screws out of there. Done. I'll shake some of these screws out. They're a bit longer than the other ones, but it still seems to be stubbornly not coming apart yet. So I'm going to have to look to see if there's anything else that's hidden that's preventing it from coming apart. So there's a sort of gap there that I need to get a flat screwdriver down to show you. So I guess I'm going to have to sort of pry along that seam there in order to separate the back, to get the back off basically. So I managed to pried it open, and it was a bit of a struggle, but it looks like there's sort of like a two-piece to it. It's like the back contains components like the mains transformer and some other, maybe a suppressor circuit or something, you know, to dampen out any voltage spikes. For that capacitor's well and truly kaput, by the way. Look at that. Totally fried. I mean, that thing is knackered. No wonder it wasn't working. I'll have to show her that, because that would explain why it isn't worked. That's totally and utterly knackered. So there's no danger that's going to work in a hurry. And I think that's, well, looking at the wire, and that's high voltage, that's the mains input. That's the transformer, and that's sort of like something to do with the power supply. It's got these heat sinks on these transistors, and there's diodes and all sorts. But that capacitor there is fried. So but it's made up of this sort of components in the back as well. That vent there is to cool the transformer. In fact, there's the battery terminals there, that's where the batteries would go. So that's definitely the power side of the circuit. The blue wires are definitely, and of course the white wire, that would be coming from the battery. Just think we'll stay still for a minute. Right, so that's the batteries, the battery wires. That wire leads all the way to this bit here. I don't know if that came up very well, maybe you zoomed in a bit. Right, so there, I'll read it again. That's the batteries, and it follows that route and makes contact with the board there. But the mains input, which is the bit where the plug goes on the end, that goes into the transformer first to get the voltage stepped down, the smaller voltage. And this is a transformer here. And then out the transformer it comes into this probably suppressor circuit to filter out, you know, smooth out the voltage. And then from there you've got this ribbon wire that seems to go to the board here. So that's your main speakers, and it's damp, there's some sort of residue in there. It's magnetic, that's how a speaker works. Uses the magnet, coil of wire in there, and electromagnetic forces which used to vibrate the paper cone. That's the paper cone. It even sounds like white noise when I do that. And the same with this being stereo. It's fine. That's actually just glue. But the coils are down in there anyway for the speaker cone. That looks like the microprocessor. So I'll take more of this apart. First thing I'll do is I'll get this separated, the back completely separated from the rest of it. Now to do that I'm going to have to take and plug this connector here and in there. I think that's possibly clamped down there as well. Speaker, the battery wire. So I'm going to do that. So these plugs are I just pulled on those to remove them. They just pushed to fit on, but the battery wires are soldered on. So I'm just going to pull them out or just snip them off. I've got a pair of snips, doesn't really matter. And I think that would actually separate this thing. There's this earth wire or something. There's that the aerial. That would be the aerial lead that comes through the back. Yeah, and that goes through the back here. That adhesive there, I think it's just to stop it from pulling directly on the circuit board. So this gets snagged. There's even a knot there as well to prevent it from pulling against the direct solder connection there. Glue it down there too. So it's pulling against that instead. Or alternatively, we could have put a knot there so that it would pull against the knot rather than pull against the actual solder from the circuit board. But I'll just snip these off to get this back completely removed from the rest of it. So because this isn't going back together again, it doesn't really matter how I snip it. It doesn't matter, it's going to be going up anyway. So I'll just cut that simply like that and like that. These snips, and that will then free the back from the rest of the device. Now, this seems to be the main, it's upside down at the moment. So the main deal, that's the power side of things. That's the transformer and the suppressor circuit. I could probably take them out later, but first things first, I'll take this apart. I'll just show you as well. It's quite heavy because it's got a steel big metal core inside there for the plates, for the windings to go around for the induction system. That's how the induction voltage works in the transformer. There's the gear mechanisms for the door opening. So I wonder if I could actually do it manually. In fact, I'm just turning it manually with my finger, and it seems to be doing this. And just basically driving the so that's opened it, and the laser will be, the head for the laser will be there, the CD will go into here, it'll spin, and that would be the laser head there. That's the platter for the, well, that bit spins for the CD to rest on. That'll turn and spin the CD. That's the laser sign warning. Oh, right. So these gears basically turn against the teeth on there. Look, I don't know if you can see that. So that is turning that gear, which turns that gear, which engages with the teeth on there, which will move the door open, up or down rather. So that, you can see this, it's easy. Let me zoom out, actually might help me. Filming with one hand and doing this with the other's not that easy. So a slide, you can't really slide the door manually like that. Well, you could actually, for some reason, I didn't know that. Okay, so you can slide the door manually. You might even hear the gears. Sometimes you can't turn against the gears. In this case you can. You can maybe hear that as well. So straight cut gears, meaning that they're straight, they're not beveled, and that's for strength, and it's a bit noisier that way. But it's the last, so it's quite strong. Straight cut gears, plastic or nylon gears. So I'm going to actually just leave it closed for now, because what I'm going to do is take the circuit board, this top circuit board off, and it's a Phillips screwdriver required to do that, to remove these 4 Phillips screws. So there was wee washers that came out of them as well on that one, I think. So there must have been a ribbon connector that came off there. It just came off of there. That came off of there. And there's this connector. That's another connector plug that comes off. This circuit board's full of connectors. So if I pull all them off, including the ribbon ones, which is what I'm doing now, and I should be able to separate that board from the rest of it. So I'm doing it with my left arm. I'm just going to put this phone down. I'll tell you what, I'll continue doing it. You can see how it's locked in anyway. You saw how these connectors were locked, and it was just a push fit into the corresponding sockets on the board. Now there's a couple of wires, there's 4 wires that are actually soldered directly to the board, which I'll need to snip. Well, there's 5 wires. I'm going to snip them and get this board removed completely. And I'll do the last one, I'll feel it. Just like that. I've done that with the other 4, and I've removed this circuit board. And the solder on the other side is quite sharp. Now I'm getting into the sort of laser part. That's the motor for the, probably for driving the heads, or one of them will be, well, that's the motor for, I think, the heads. I'm not quite sure what that one's for. It's maybe for moving the platter. One will be for spinning the disc, and one will be for moving the laser head, to track the laser head. You can see the gearing in it. This motor here will be used for driving the gears to open the door at the top, to slide that door open. That was the one that I demonstrated earlier by doing that. You might be able to see how the gears are all connected. It's a little bit sore in my fingers, that, but I don't know how else I could show you, because I'm holding the camera with one hand. Maybe if I use my stand, camera stand, but there's a wee belt in there as well. Belt driven, you might be able to just see that. So this belt here, which I've just taken off, it's just a very small, like elastic band type belt. It's a bit tougher than an elastic band. That's the drive motor, and that just basically, that belt goes on there to drive the gears for opening this door. So now once the door will be a lot easier to open, because it's not driving the belt. And that's just the transfer gear for opening the other side as well, you know, to have it balanced. So there's gears on gears on that side and gears on that side, and that's just transfer shaft that goes right along there. So I don't know how well you can see that, but it's the best I could do. So that's the gearing for that. Now these motors, as I say, I think that will be for driving the head. So this motor, I think, will, well, it looks as though that motor is for turning the CD. Yeah, quite convinced of it. And the other one, because these heads have got to move along here basically to track the CD as it's playing through the song, and you might see a wee gear down there. And try to demonstrate. I've moved that wire out of the road, I've just pulled it off. You might see that. So as I'm doing that, you might see the motor, you might see this sliding along the shaft. That's the heads, that's the laser heads. It looks as though that gear is what's, you can see that now. So if you watch this, you can see it moving along. That's the guide rail. So that gear, that motor there, that motor will drive that gear down there, which is going to cause this to move along that guide rail. Now, to show you the gearing, I might have to remove the whole unit, and to do that I'm going to have to remove these small Phillips screws, 4 of them at each corner. So one thing I've noticed, one observation I've noticed regarding the old equipment like that, I think that was probably made in the 90s or maybe even the late 80s, is that there's a lot more components in the older stuff than what there is on the more modern things. The more modern electronic appliances tend to use microprocessors, which eliminates a lot of the circuit boards there. So, but this being a fairly early model that's got a lot of parts in it, which makes it more interesting to look at. So, and all the explanations I'm giving you is just from the knowledge that I've gathered through my own time. I'm not a fully qualified, I'm not a qualified electrician, as I said earlier. My dad is, he's a lot more clued up in all the technical stuff, but it's my video, I've got to do this for my own video. It's not my dad's video, it's my video, and I'm just telling you my understanding of it. Besides, my dad's out taking my brother out on this lovely day, whereas I'd be out the back here doing this instead. Well, yesterday I'd done an adventure anyway. I've done that in another video, but that's for another video. So back to the task at hand. So yeah, well, most people are out enjoying the good weather. I do my own thing, and one of them is taking this apart. I can do whatever I want really. It's just what I've always done. So I'm going to remove. Now you might notice that there's a rubber cushion there. Because this is a laser and it's very delicate and sensitive, they put these rubber mounts here to absorb any shocks, because any vibrations that would upset the CD player, you know, because it's very fragile or very delicate, sensitive for movement. So they want to eliminate that. So they use these rubber. You see it down there as well. Good. Try and show you. It's down there. You can see kind of how it's buffering out any movement. It cushions out, dampens out any vibrations basically. Because the CD's spinning at high speed and the CD's spinning around, that laser's very accurate. This is very sensitive, so they've got to, you know, have it cushioned, because any movement inside, any knocks or bumps or anything like that will upset it easily otherwise. So I've got Well, there's the other one anyway, I'll show you what it looks like. Just lift it. That's the rubber shock absorber. Not a peg, which I pulled off, which will cause this to separate once I remove. Oh, there you go, you can see it coming off there. This is a laser assembly, and I've unplugged it. This is the laser head assembly, and you can probably see a lot clearer now. Yeah, you can probably hear it. Now, it wouldn't go as fast as that. I mean, if it's a long CD, then it'll just move very slowly as the music's playing on. You might even be able to hear the gears. Now, because I'm pushing past faster than it would ever be driven when it's in use, you could hear it skipping the gears. That's that noise. And you can see it's a direct drive for the spinning the platter. So the motor for spinning the CD is not even geared, it's just a direct drive right to the platter, so it's going to spin very fast. These motors, when they do work, they need to be geared in order to reduce the speed, but at the same time increase the torque accordingly. So as the speed is decreased, the torque is increased proportionally due to the gearing ratio. And the torque is what's responsible for the turning force, the effort. That's what's needed to actually mechanically move something like this. Whereas the CD will just sit in this platter. Now, it's not really doing anything other than spinning a CD, and it's quite light, so it doesn't really need any gearing. But the motor will drive at a fast RPM. The CD needs to be spinning at a very fast RPM. So it's just a direct drive shaft right from the motor output to this platter where the CD will rest on. It will sit on there. There's little wee screws there. They might be weight balanced, I don't know. They might be there to act as a weight, perhaps, for the centrifugal force, like when you're I'm not sure, to be honest. I'm guessing it's maybe just a weight or something, because like, if you're like on a car, if your wheel's spinning and it's unbalanced, you'll get a vibration right the way through the steering wheel. It's horrible. And that, what they do is the tyre places add a weight to the wheel. Now, I don't know if that's what this is. My dad's not here. Sometimes I wished he was. I could ask him, he would probably give you a better idea. But I'm just guessing that that's what these things are. Unless it's there to lock the CD in as well. Maybe it's a ball bearing. So when you put the CD on there, the CD rolls over that ball, and then it will situate itself, and that locks the CD in. So when it comes to lifting the CD out, all you're doing is pushing against the spring on this. The CD will, the edge of the inner, the hole on the inside of the circumference of the CD will just roll over this ball, but at the same time it won't like do any damage because it's just the ball bearing. But the spring loadedness of the ball bearing, then when you come to putting the CD on there, that will roll over the edge, the inner. Like, imagine if that's the CD, right? That hole there, well, that edge, that inner edge will roll over that ball, and it will fit underneath it. And then once it's done that, that spring will then spring this little ball bearing back up, which will lock the CD between the ball and the platter. And when it comes to lifting the CD out, you're just lifting it over, you're just rolling it over. You're rolling that inner edge, the hole of the inner, the edge of the inner hole, you're just rolling it over that ball bearing and pushing against the spring at the same time. Now they're 120 degrees apart. I could only guess that that's what that's for, to keep the CD on there whilst it's spinning at fast speeds and locks it in. But in a method where it's not actually wearing it out as you're lifting it in and out, it's just going over the ball bearing. So it's a smooth surface, spring loaded. That could only be my understanding of it. Anyhow, that's the laser mechanism there, and these damper shock absorber things just fit over the I just fit one like that as such. You can see how I take them off. Putting them on will be a reversal of removal. And the motors are just all integrated with this whole thing. It's non-serviceable. I think if this thing's knackered, the repairman will just simply replace this as a unit. I don't think this is serviceable. That would be a specialist job to service one of these. So like I say, if this broke down and the repairman comes up, he would just take this out as a unit and then swap it out, rather than try to dismantle all this. And this might get sent away to a place that will specialise in it, recondition it, and then, you know, put it back on as a spare. Right, next task. So like I say, these things, because they're older in design, there's a lot more parts to them, and it takes a wee bit of time to get through them all. It's more densely packed with components. Whereas if it's a modern thing, I've took a DVD player apart before, a fairly modern one, there was a lot less in it, because see, a lot of the circuit boards and that, the suppressors, the main suppressor circuit board, it's all miniaturised. It's all been, as technology goes on, all the components get smaller but more sophisticated at the same time, by means of the microprocessors and all that, silicon chip. That's a very rudimentary description of it. It's a semiconductor. Right, so I'm going to get back into this now. I don't want to get sort of like getting into all that, but these things are very sophisticated things, and as technology goes on, the more logic computing power that they're capable of doing, which eliminates more circuit boards. I don't have a plan, as you probably heard me saying before in my videos. If I don't have a plan, I just make it up as I go along, and I'll just wing it. So I'm going to remove this circuit board here and have a wee look down there. And to do that, looks as though it's the same old drill, Phillips screws, same old procedure. Remove these Phillips screws. So far all the screws that I've took out they've been Phillips, and Phillips are easier because they tend not to round as easy as if it were just a flat screwdriver type. With these chrome screws removed, the circuit board, oh, there's one layer hidden there, if you don't have to take that out. I didn't spot that one that was hidden with all these wires above it. Might as well just film this in real time. Right, 4 screws removed, circuit board removed, bar one wire that's soldered on. I'll just simply, I can yank it off, which I just did. I just brutally yanked it off, I couldn't be bothered getting the snips to do it. That's the aerial, I think, maybe not, I don't know. I'm not quite sure what this board's all about, but it's got fairly, I think it's a tuning board actually, because if I remember right, I think that's something to do with the tuner system, or I think if you see when you mess around with this, that completely knackers up everything, because this is all factory set, these adjusters are all factory set, and I think this is something to do with the, like a tuner now. I don't even know if this thing had a radio function on it. It must have had a radio, so yeah. USB, so it's not 90s anyway. Be later than that, there might be a date in there. But yeah, I think that's, but then it's not got any heat shielding or reflective silver shielding over it, because usually tuner circuits have a reflector silver casing to deflect, which will deflect any interference signals. I'm not actually sure what this big long coil inductor like thing is. I'm not sure yet. So for now I'm just going to have to put it aside, and I'm going to just simply move on to this circuit board and remove this one and have a look at that and see what's revealed on the other side of it. And it's the same old story. Phillips screws, 4 of them, 2 at the top, 2 here, and I think actually there's 5, there's 1 there as well. So I'm just going to turn it anti-clockwise, pull the screws out, times 5, and that circuit board should come up. I won't bother filming all that. I could remove these screws in a fraction of the time when I'm doing it with both hands, because I'm using my left hand to guide the screwdriver and my right hand to unscrew it. But because I'm filming, it takes a lot longer. I've just shown you how I filmed me taking out the last screw, just to give you, just to show you that bit. And now we're bored with all the screws out. In theory, I understand it should just come out. There's a little tab there. I have to put the phone down for a minute. It turned out there was actually a hidden screw underneath this. Now I didn't have any instructions or anything like that, but these 2 screws were covered with this insulated cardboard sort of material, and I had no way of finding that out until I yanked on the... I was thinking the thing was actually locked in with wee tabs that I had to pull in order to remove it, but the circuit board's kaput anyway, so it doesn't really matter. It's knackered, the whole thing's knackered, so it's really not like giving much care about the condition of the circuit board. Now I think this might be the buttons for the... In fact, this is the display board and the button board. So on the corresponding side, these buttons that you press, there's pegs on the other side there. So when you press these buttons, you might see them moving as I press them. These pegs make contact with the actual buttons that are on the circuit board. So that's basically what they are. And the display, liquid crystal display, that goes there. So in effect it was just like that more or less. And the buttons, when you press them, as I say, the display goes into this wheel lens, this cover, protective cover. The buttons, when you push them, these pegs, you can actually take one of them out. In fact I just pushed one, there's one of the buttons removed. You're just basically pushing this peg, which makes contact with the corresponding button on the actual electrical switch, electrical button. That's the mechanical means. That was the button that I removed. It's a chrome bit there, that's a bit that basically would go through like such, if I could demonstrate. Right, so that's there, you see it coming out. Try and show you. Right, try it again. So you can see the button, as I'm going to pull it out from the back. It simply goes through that hole. The other end, which is there, makes contact with the corresponding button on there. Now I don't know what one it was, it might be written on here. Probably that one. It seems it was that one actually. Yeah, so that's the mating button for it. That would have went like such. And that's what that is really, that's the button board. To save time, I've just snipped the wires off, pulled the other ones off to remove the circuit board completely. The circuit board is, during removal, the circuit board's kind of split right down the centre there. It's snapped more or less. Circuit board's developed a snap. Snapped it as I was trying to get it out. Kind of like, I wasn't really giving it much care because it's getting chopped in the skip anyway. So, but picked up this brake along the way, but it doesn't matter. It's not important. As I say, it's all going in the skip at the end of the day. So next task, I'm going to remove the speakers. Now you can see demonstrating it, the magnet is in the demonstrating the magnetic force from the cone magnet. To remove this, I think it's a nylon clamps here. Now this is done in a way to absorb vibrations, so they've kind of like clamped it down on plastic, and I think the screws in this plastic bit here acts as a damper as well, so that the speaker vibrations don't vibrate the casing, which would upset the acoustics of the whole thing. These were also quite a sharp Phillips screw. I had to use a different screwdriver. Now you could hear it crack as I slacken them. I think that's because they're also Loctited as well. Because a speaker in its nature is all about vibrating air molecules, that's, the paper cone does that. That's what produces the sound. So if these screws were slack in any way, you would get this annoying buzzing sound, this annoying vibration sound from the casing, which would just interfere with the acoustics of the music. It would be really annoying. So make sure that the speaker is firmly attached to the casing and dampen any vibrations that would otherwise resonate through the whole bodywork of this whole, through the casing, and it would just be producing an annoying resonating buzz. So they're trying to eliminate that by securing the speaker in a certain way. They have to take care in how they secure it to the casing. Now there is another speaker as well, as a tweeter, so it was probably quite a good quality. It is a hi-fi after all, so they do. This is the sharper Phillips screwdriver, by the way. Yeah, so they do go an extra mile to give you a good quality sound, because one single speaker wouldn't be able to produce the same sound as a multi-speaker setup, because it's limited, you see. So this will be for the high pitch frequencies, and this is obviously for your main frequencies. A bit more power. In fact, the power rating's on it. 4 ohms, 5 watts. The tweeter, 25 watts, I think that is, which is quite high. I wouldn't have thought it would have been that high, but anyway, so it's got written on it. I presume anyway, that's what W stands for, watts. Anyway, I'll take off the other one as well. Might as well remove that too. And I'll film the last screw coming out on this one. Oh, this is going to be the awkward one. Yeah, this is going to be the awkward one, because I'm filming it. What's actually happening is that the screw is rounding. Now it's never done that before, but it doesn't matter. I'll break it out. I'll get it out. The speaker's coming out one way or another. It doesn't really matter how we do it, because as I say, the whole thing's going in the skip. I was hoping to show you that coming out nice and easily. In fact, I'll make up for it. You've seen it on the other side anyway, but I'll let you see this one coming out. This one's, I don't know why that screw's rounded all of a sudden. I didn't put any effort on it. It's a sharp Phillips, but somehow it's rounded. The head is rounded, but it's no big deal really. It takes so much longer when I'm using my left hand, and right-handed as well, you see, and then filming with my right hand. Right, let's get this one out. I'll just do what's necessary to get it out. What I had to do is I had to actually press really hard the screwdriver in order to get it to turn. I've got it out. It was just because the screwdriver was just slipping inside it. So the speaker wires are adhesive in there, because the wires themselves are set up in oscillating frequency otherwise. So that makes sure everything's tied it down. There's no anything that could vibrate, because it will just cause a horrible vibrating sound, which wouldn't be any good for a hi-fi system. So there's both speakers out. The casing is now considerably lighter. The main drive mechanism for the door, well, that's the gearing and all the rest of it. I could probably dismantle all that and show you all the wee parts. In fact, I'll get a clearer view of the door now, but drive shaft. So as I say, I took the belt off earlier. That's it there. And all this is gone. That is it's the heads and the platter that would normally be there. The buttons, those all gone. I'm going to dismantle this bit now. So to do that, it was just a couple of Phillips screws that went in there, that slackened, and the motor, that's where the, I think that's where the screws went in. But the motor just fell out anyway when I took these screws out. So that just leaves the gearbox bit, which seems to be held in with that and that one as well. So I'll go and remove that and see what happens. So again, that's firmly screwed in with some sort of Loctite or something, because it makes a cracking sound when I slacken it. You might hear it this time. Yeah, you might have just heard that. Again, because there's a lot of moving parts in there and an integrate gearing system, you don't want anything coming slack, because naturally when there's mechanisms involved there's going to be an element of vibration, and the last thing they want is anything to work loose. So these screws are really quite long, and I'm sure that when they made that cracking sound as I slackened them initially, it could have been Loctite. Loctite's just a form of adhesive that goes on the thread of the screw there to prevent it from slackening them off. Typical. Right, so with the screws off, it should just lift out. The gearbox, in fact, does lift out. That's the drive for the opening the door. And that motor went through like that. So I've actually put the belt back on again just to show you. So the motor is fixed to the plastic, and the belt is what's used to drive this gear, and you could, well, it drives this pulley bit of the gear, and then at the other side we've got this gear here that makes engagement with this gear. It's all geared with the number of teeth for the ratio in order to control the speed and torque. And the drive shaft, this gear here makes contact with the pinion on this drive shaft in order to drive the other side of the door as well. So it's getting equally driven. So this door has not got anything to resist it now. That will just simply fall down under its own weight. And you can see how the gears, there's another gear there that makes contact with the rate gear for this gear mechanism. The teeth basically on there. That's like a rack. I think that would be called a rack and pinion, isn't it? That's the gear rack. That's the rack. That'll be the pinion. That's the rack. That's the pinion, and that's the gearing. So it's rack and pinion, like that of a car steering. So it's just like turning effort going into linear movement uses a rack and pinion method. So in a way that would be like a car. That would be it going left, turning the track rods, the track controls towards me, which would be turning the car left if that was the front, and if it was turning the steering wheel to the right, you can see then that would move the track arms this way, which would push the wheels like that to turn it right. That's how the turning movement from a steering wheel, for example, is moved into linear movement. by means of a rack and pinion. Well, rack and pinion. Rack and pinion, like rack and pinion steering. And because a car is very heavy at the front, in terms of relations for human beings, it would take a lot of effort to move the wheels. So they need to have a gearing method. They have a big steering wheel, which is your leverage, because you're turning the big wheel, but it's going into moving so many gears, and the gear ratio between the movement of the steering wheel is like multiplying the torque to give you a small movement, you know, linear movement, in order to give enough force to move the wheel. And talking for your rack and pinion on a car steering system. Well, it's the same here. Well, it's just like rack and pinion. It works on a similar principle. Turning force here, causing the door to move, in this case, up, not down. So that was that. The door actually off. To get the door off, I think there's going to be these screws there that might need to come out in order to unclamp the door. So let's just see what happens anyway. Let's remove them and see if this jigsaw puzzle will come apart, because there wouldn't really be much benefit in taking the door off, but I'm going to take it off anyway, just to closer inspection. It's coming apart this way. Now I don't want to take it out yet because this came off, and I want to see how it's actually locked in first to ensure it with you. So I've removed partially these screws, I've slackened them right off. That black bit there came off. So what's happening here now is it, put the light on for this, see what's actually going on. So the door's ready to come right off now. It's just come right off. So there's obviously like a guide. So it goes down there then. So to reassemble it again, I just want to, again, these guides have got a critical part to play in it. It's also greased as well, by the way, so you can see the 3 screw holes correspondingly going there. So this one is still in there partly, but this one I've slackened. You can see it's quite loose. I've slackened them. Let me just see how this door thing, I think the day bits there, trim will go down there. Let's just try that. Put the door back on again. You might just sort of see what's going on now, I hope. This is the runner for the door. That's that plastic bit on the other side. That's the left hand side runner. The right hand side runner is still on the unit. These locking tabs make they go down there, and the door is firmly down. When the door's open, so I've got a bit of an understanding how how the door actually is connected to the unit. So when I pull it out, it will just come right out. That's the rack gear. That's the runner, which the rack gear goes along. So that's really just the runner when I took these screws. 3 screws on each. So yeah, these three screws are what holds the runner in the unit. I think it might be like a micro switch sensor to sense when the door has reached the top. Obviously it needs to know when the door's maximum out. So when these switches are activated, cut the power to the motor. That's the micro switches. Well, unfortunately it's just part accompanied, but yeah, so when the door reaches a maximum, a certain point, these bits there will make contact. I don't know if you see this. Possibly them bits will press up against the switch, and then that would be detected, and then it will tell the motherboard, the circuit board, the main control board or module, whatever's responsible for that, to cut the power to the motor so it doesn't keep driving the door further up. It's reached the top basically, and vice versa. When it reaches the bottom, there'll be a similar switch at the bottom. I think that'll be it there. Possibly that one there. And when it reaches the bottom, detect. I don't know just exactly how it works, but I'm just taking a guess. So there's a little light or something. I don't know, I've never seen this thing working. That might be a wee light. It might light up when it's switched on, because there is a circuit board. It looks like that's an LED or a wee bulb or something, probably an LED. And when it's switched on, I'm guessing that'll light up. I'll have to ask her. I'm sure they'll remember, but as I say, I haven't had any dealings with this before. I've never, not that I could remember, but it was just, if it was maybe just switched on and it had just been there. I wouldn't have paid a great deal of attention to it if it was, but I've had it for a long time anyway. But they've also had it for a long time while it was in storage. When they discovered it was knackered, I think I just stored it away or something. And then during the clean out, they decided to give it to me to do a video on. So yeah, I think that is a light, by the way. It's a diode, a light emitting diode. I'm guessing it. That acrylic, so there'll be another light. So it's probably a light. This white thing here will be a light. We'll channel the light along. That'll be like a wee lens or something. That's what will cause that to light up. I don't know what colour it lights up. And there's also another wee light on there as well. It would probably be there or something. Unless it's maybe just. I don't can see that very well in here. I'll turn this. It's definitely a diode 4. So in order to trace where that other light is, I've put this back together again. I've not screwed it in, I've just positioned it back together. So that diode's on this side, so I'm trying to back trace where it would go. It doesn't seem to go, so maybe there's a wee light there for whatever reason. I thought actually that was a sensor. It might be a sensor, it might be an optical sensor actually, I don't know. So when this reaches the bottom, there'll be an optical sensor that tells the motor to switch off. Unless that's a light that lights up the inside of this thing, just to make it look smarter. As I say, I've never seen it working, so that might shine a wee light out there when you put the CD in there. Possibly that, I don't know, but I'm sure this name badge will be lit up with this other LED. There's 2 lighting diodes in there. That's for the name badge one, and that's for this, probably lighting up the doorway bit. Or it may be an optical sensor. I just don't know, to be fair. But it's pretty standard, basic. Not very much to it. So there's these bits here. I don't know what they are. I'm going to remove those and see what's under those. Oh, I've took one of them out. Well, that's still in. I've unscrewed it, but it's still in situ. Took this one out. I think this is a wee micro switch. And I'll see what it says on it as well. And that was the micro switches after all, yeah, because that's the corresponding side to it. So that yeah, that's exactly what it is. That's exactly what that is. Yep. That's the other one. That's for telling the sensor, that's the sensors for telling the circuits, you know, that the door is up to its maximum or if the door's closed. It might act as 2, either it'll act to deter whether the door's right at the bottom, fully bottomed out, or at top dead centre, or right at the top. So if it reaches the top, it'll maybe close the circuit. If it reaches the bottom, it might open it, I don't know. But that's definitely a wee micro switch of some sort. The silver bit's broke off the other one, but the wee red bit is the actual switch, the mechanical bit. You might even hear it clicking. So there's basically a sensor anyway. I would say it's to do with the door, to detect whether it's fully closed or fully at the bottom. Well, that's really all the electrical stuff. I could maybe take the top drive, transfer drive out, this drive shaft sort of thing. To remove the shaft, it's just like this plastic bit. I've unscrewed it. It's just, on the other side, it's still in situ. This one, I've took the 2 Phillips screws. You might see it, one of them's down there. It just sort of screws in like that, so it holds it in place. Well, I've took 2 screws out, it's now released, and that's fitted permanently to the shaft. I'll remove the other one as well. So that's the top rail or top upper drive shaft with the pinions at both ends removed, and that's for, as I say, opening up the door. That's part of the door mechanism. And these pinions will probably just pull out. They do indeed. There's just free resting in there. Can't show you. There's not really any reason to have that locked in because it's all held together anyway. When this drive shaft thing's locked in, that gear is engaged with that anyway, so that won't come out because this will be over it. And this shaft's locked in with the two clamps that go in there. Right, take it out anyway. There you go, there's a wee pinion gear. Right. That's the same, that's just the badge. There's nothing else really on this, no? That's the main deal of it. Coming back to this bit now. This is the back case, and this is responsible for there's some jack leads here as well. That'll be that circuit board. So they've also got the power side of things. This bit's all to do with the power supply. To get the transformer out requires a Phillips screwdriver. So this is the high voltage side of things. This is the lethal. Well, it's all, you assume it's all lethal. You know, just basically you don't take any chances with anything that's electrical. But I know this is definitely the mains transformer, and that's the bit that plugs into the wall basically. Cable goes right into here. So this is the mains voltage bit, and that is lethal when it's plugged in and switched on. The transformer is quite a heavy component. It's probably the heaviest component in the whole thing, and then the speakers will be next because of the big magnet on there. That's quite heavy. So speakers and transformer is definitely the heaviest components in it. I'm going to need the flat screwdriver for the different sharper Phillips for that. I've actually slackened these off and just removing this grommet control cable. Now that's knotted, that's to take up slack. It's also adhesive thinned as well. So when this flex is pulled, it doesn't pull directly onto the transformer. So they put all this stuff here, so when you're pulling this by accident, it's pulling against this rather than the electrical connector side of things. Now I've got 3 of the 4 screws slackened. The screwdriver is magnetic. There's screws everywhere on this thing. Now this one's a little bit corroded for whatever reason, and it is definitely rounded. And that will definitely prove a challenge to get out. So I've got 3 of the screws out for the transformer. But unfortunately the other one isn't moving, so I'll get the 3 out, then I'll maybe just yank the thing out and get it out that way, just break it out. So I'm only really resisting against one screw. This one here is rounded completely. I don't have a sharper or just a sharp enough Phillips screwdriver to get it out. It's completely rounded, you can see it anyway. It's corrosion that does that, so I'll just basically break it out So when the going gets tough, I just get my big crowbar like flat screwdriver to wrench it out. That's just like what they do in the scrapyards, so they used to do, they just crowbar to break things off, you know. That'll get it out. It was quite easy, it came out without any difficulty really. One wrench and it was out. Snip the main wires. And then that's it. That's your main transformer. Mains voltage. Power supply. Presumably it comes out with 12 volts. So you're plugging it into the wall. It goes directly into the transformer. It's transformed down. And then from there, these blue wires went into this suppressor circuit where the blown capacitor is. It's well and truly blown like. I'll get the circuit board out as well and show you the other side of it. That's just to iron out the voltage, just to make the voltage smoother before it goes into all the electronics of this stereo. The last thing you want is voltage to be unstable, because all this electronic stuff is fragile, sensitive. So you want a nice, smooth, clean voltage going in, and that circuit board there is responsible for it. But like I said, don't quote me 100% on that. I'm just giving you my understanding of it. Like I said at the start of the video, this video is only for entertainment purposes, and I'm only giving you my understanding for it, and that's it. So don't quote me. I'm only guessing that that's what these components are for. Right, now, next task. I think a flat Phillips screwdriver. I'm going to get in to removing this circuit board. It might just be one screw that holds this in. It seems as though it is just one Phillips screw. Nice and easy. And out it comes. It just came off that peg, like that double peg there. So there's a wee hole on there, that kind of cating hole for the circuit board and the locking screw. Now to get it out of the whole thing, I have to just yank it out. I just pulled on it because the cables were tied down with this adhesive, like glue-like substance. So all I done was just pull gently, very much force, and it just comes free. And now I've got the knackered suppressor board circuit out. It was fried. I mean, it's completely fried. Both the capacitors, 3 of them are knackered. In fact, well, it's ugly. It's horrible. Yuck. Oh God. I'm guessing it would make a kind of like an electrical burning smell when that happened. But it looks disgusting. So it's fair to say that was probably the root cause problem with this whole thing not working. If there were anything else wrong yet, then there might be other faults with it, but I definitely reckon that would be one major contributor to it. Because if that happened to begin with, nothing else would work after it. So it might have developed faults throughout, and then that would have been like the final fault. Now this circuit board here that I'm taking out is for the input jack plugs, radio or whatever, these jack plug things. You'll probably see in a minute. Yeah, they're out the come. So they just go through that. They just go through that basically. And again, it's easy. Just pull down on it. So I've got to show you this and do this at the same time. Now I've got my sore hand and my sore wrist, and I'm going to be doing that, so I want to put the phone down. I just had to use my other hand. I don't want to be straining my left wrist anymore, not over the is. Just for a video. Now they don't look too healthy neither. They don't look too healthy. And that's brown. I think the resistors are burned out. Something's not right anyway. I mean, it's definitely not right with that. It shouldn't be that colour, I would have thought. No, that's just the battery loop cables. They just, well, it's just contacts on the other side. And the battery was leaking by the looks of it as well, because there's sort of like, you can see that it's wet. It's an alkali battery. So that's really just the other side of it. That went to the circuit board that I showed you earlier at the start of the video when I first took the back off. So that's the back, completely disassembled. I don't know what this is about, this metal plate. It might just be a reinforcing plate, because when it's used on the stand, I'm going to make it plastic a wee bit stiffer, otherwise it would crack the plastic, that's my guess. Just try to show you this. The stand goes in like such, these pegs bit go in there. It's hard to show you this and do this at the same time, but they're going in there, and at the other side of that there's that metal bit. So that metal bit there, I think it's just a reinforcer, because obviously it supports the weight of the whole unit. So if that metal bit wasn't there, that plastic might crack quite easily through wear and tear. So they've just reinforced it by putting this. We can try and demonstrate the sound. It's a bit of plate metal. That could only be my guess as to what that is. And that's just the aerial lead that going through the back. Again, it's adhesive in, just to probably just pull right through now. It's just a bit of wire, there's nothing really to it. There is another knot on the other side to stop it from pulling out. So, and they say that's just battery leads, nothing, that just goes to the connectors there. Nothing exciting there. Basically what you see there is what there is. Well, I think I've pretty much dismantled it all. Can't think of anything else. Pretty much it. Still not quite sure what that is. If it's an aerial going into it, it suggests to me that it must have been a radio function as well, which would then mean that this is maybe something to do with the tuner system, because it's got like a capacitors and a coil of wire on this. There's a name for this now, Kleister or something, I can't remember, but there's a name for this. It was in my dad's old stereo as well, the Philips. No, it was the Goodman's Module 90 amplifier from 1974. I didn't take it apart like this, I just took the bottom cover off and I had something like this inside it. But the other amplifier I've done a separate video of, and I got it sent away for restoration, but got it back and it works brilliant. But inside our old Goodman's Module 90 amplifier, tuner amplifier, because it's got a radio as well. It acts as a radio and it acts as an amplifier for the input for the record player, and also for an auxiliary, which could be a CD player or tape player even. Well, anyway, I had one of these inside it, and I reckon it's something to do with the radio tuner. Right, that's it for now. Right, the next task now for me is to get all the bits here behind me on this table, to get them all put into a kind of like a neat orderly fashion, so I could summarise what the parts are and show you the systems individually. So at the moment it just looks like a dog's dinner. It's just a bloody mess at the moment, so I'm going to try and get this into some sort of order so you could kind of get a better understanding of the individual systems. So I'm going to start doing this now. First thing I'll do is I'll put the bag, dodgy batteries in it, plastic casing, so I'll start working my way through that now. So actually, during tidying all this up, amongst all the mess, I remember this remote control was buried, and I now remembered this came with the remote. So what I'll do before I summarise, I'm going to take this remote control apart as well. So yeah, like I was saying, this was buried amongst all this stuff. So I might as well dismantle this, seeing it's come with it. First thing I'll do is I'll get the battery cover off. There's no batteries in it. It reveals 2 Phillips screws, very small ones. I assume if I take them off, this whole thing will come apart. But it's a very small Phillips screw, so I'm just going to have to dig one of them out. Hopefully I could find one. So I managed to find a wee Phillips screwdriver, and it's doing the job. And they're tiny, these screws. So with the Phillips screws out, It looks as though it needs to be pried. I can't see any other way to open it. It doesn't seem to be any other locking screws or any other fixtures. I think it's just the tabs or something, so I need to go along with that wee flat screwdriver and just pry this open to pry it apart. I managed to pry it apart, but ridiculously there was another screw hidden. I mean, there it is there, look. I can only assume that's what was holding it in, because there was a bit of breaking plastic. Now that's hidden. How on earth am I meant to see that? Under here. That button control hides that screw. So how the heck am I supposed to know that? How are you supposed to get into that screw? The other two were easy. But no wonder it was resistant to get open. I mean, that, I don't have an instruction, but I don't think that peels off this cover. So that seems a bit odd to me. How did they manage to manufacture it as well? I mean, does this panel would come off or something? Or it's crazy. I mean, you can see it's broke. It must be. I'm guessing it's non-serviceable, but I mean, I don't even know how they managed to do it. But that's twice now I've been caught up with a screw that's been hidden deliberately. This bit of cardboard hid a couple of screws with a circuit board. I think it was that one. And I only realised it when I peeled this back. And the remote control, the two screws that are sensibly positioned so you can see them, and they move them, they two come out without any difficulty. But this third screw is hidden with that. It's nuts. So as I say, that's just my experience of it. I don't know how that, there's maybe a procedure I don't know of, but to me that seems as though that screw is well and truly hidden under the button pad. How are you meant to know that was there unless you x-ray the thing? But anyway, doesn't matter, it's getting chucked in the skip anyway when I finish with it. But I've got it open, let's have a closer look inside it. So, that's the back cover with the hidden screw, and the button pad, the infrared, that would be the infrared emitter. So I'm just thinking now, the sensor, that will be the infrared sensor on the device, and that will be part of the switchboard. So let's see if we can trace it. Right, so that's the display, there's all the buttons, that's the USB in lead, that's the headphone jack lead, jack plug, or socket rather. This is the infrared sensor. This here. See if we could get it up a bit further. Not really much to see anyway, but that's the infrared sensor. We'll see if we could get what's written on it. PC 3388. That'll be the component number. So that's the emitter, sends infrared radiation out. That receives it, and then it controls the hi-fi. So the buttons, the wee circuit board, to get into that, I think the only way would be to break into it, because it doesn't look as though there's any other way. It's a sealed for life thing, I reckon. So I'm going to do just that. I'm just going to break into it to see the circuit board. So what I've done is I just simply snapped the plastic bit off, and that reveals the very finely made circuit board with the buttons. That's the infrared emitter. It's very finely made. It's the battery terminals. The buttons, I peel them back. They just seem to be adhesive on. Oh yeah, there we go. So we're just brutally ripping them apart. So the buttons are pressed in the number 5. So when you press that, this bit at the back must cause this resistor sensor to make or break a circuit. It's maybe just a simple case of that when you press this remote very fine. material. Sort of demonstrate. I can feel it. Sort of like it's like a very small bubble wrap kind of feeling. It just pushes down and springs back up. But when you push down on it, that black bit there makes contact with this, with one of those, with the corresponding one. So number 5, that'll be number 5 there. So I'm guessing that'll make the circuit. It'll make contact, close that circuit, which will send the pro plate signal, because there has to be a infrared, I don't know, decoder or encoder, encodes it. I must send a coded signal to this emitter that sends the infrared radiation out to the receiver, which will have to then decode that, and the instructions will be decided with the main circuit board here, which I presume will be the main decision making board with all the microprocessors on it. So I'm going to have to wrap this video up because it's a bit longer than I thought, and I've got a few things to do later on tonight. I said I'd be there, so I'm going to have to get going. I don't want to be late again. I'm going to have to be very quick here now. So what I'm going to do now is I'm going to continue on with the putting all that stuff into some kind of orderly fashion, and I'm just going to have to quickly go over it and just make a very brief summary of the internal workings of this old CD player. Okay, so I've just took a few pictures, a few photos of it, as it was kind of like in this order. So I'm just going to very quickly, briefly go through this. I don't know where to start. Right, the mains, when you plug it into the wall, your mains voltage goes in through this flex, in through this transformer, comes out of the transformer, and goes into the suppression circuit here, which will then clean the voltage up before it goes through this ribbon cable, out this connector, into one of these circuit boards, can't remember which, but it will power up the whole thing basically. The casing, the back case, that was responsible for holding the batteries, going there. Transformer was located there, suppressor circuit for the mains voltage was located there. This here is a metal reinforcing plate for the hi-fi stand. This is the main front face of the hi-fi. It's just a plastic shell right now. Incorporated in it is your button board with the pegs at the back. You've got a display lens for the liquid crystal display, infrared input sensor, headphone socket and USB plug, or socket rather. The corresponding circuit board for the buttons is here. That's digital liquid display unit. That's the buttons that these pegs here make contact to. You press them at the front, the pegs move, push against the corresponding button. USB input. USB input is there. Infrared sensor, headphone socket, headphone socket. And that's what the other side of that circuit board looks like. There's lots of wires, ribbon wires of all sorts. This here I guess is a tuning circuit board for the radio, if there was one. But there's certainly like a tuning aspect to this, I'm guessing. And that's what the other side looks like. It's your jack leads and jack plugs circuit board and corresponding wiring. There's a whole multitude of fixtures, screws, plastic clamps and even some adhesive as well. And there's a few miscellaneous gears in here, basically part of the drive system for the door that opens up, it slides up, slides down. When it slides up, it reveals the platter for the CD to go onto. So it would look like that originally. This bit would turn, the CD would go in there, this would move from side to side. So as it's playing through the tune, oh by the way that's springed, that's a spring motion, I'll maybe just demonstrate that for you. You might see it, there has to be very small springs in there to make up for any damping movement. You know, any vibrations, if this gets bumped, they don't want the CD to skip. So there's very fine springs in there to act as a suspension. I'm trying to demonstrate that, but you might see it. And it's probably like a liquid or so. It's very, very fine movement. There's this massive movement with my finger, but there's still fine movement I could see after I've done that. It's almost like it's a liquid. That won't be, I wouldn't have thought. But anyway, that's the platter for the CD and the heads, and that's the other side of it. There's 2 drive motors. That's for the driving the head, for making the head slide along here into towards the centre of the CD and out towards the circumference of the CD. It slides along, and that is the motor responsible for it. This motor here is a direct drive. That's directly responsible for driving the CD. It's a direct drive. It's just it's directly driven from the motor. This will spin at the same speed as the motor. There is no gearing. The CD will spin at the same speed as this motor. Quite a lot. This is the motor that will drive the gears, which is responsible for opening this door. This door will run on these sliders. That's the rack gear on the door, which will be driven with this pinion gear shaft, which in turn will be driven with these gears. There's a belt from the motor that drives this pulley, and on the other side of this pulley there's a gear that's bolted to it, a small pinion gear. I'll go through this gearbox to give you the right direction and the right gear ratio, and that will cause this door to move up or down as I demonstrated earlier in the video. This is the suppressor circuit that's knackered for the voltage input, the mains voltage input. The speakers, 2 speakers per side. You've got the main speaker, then you've got a tweeter speaker. So you've got one for your left and one for your right. And there, I've got a dress cover that goes over the front of the dress front panel. It would look like such, more or less. They are push fit. These pegs just push into their corresponding holes, like such. And the speaker would live behind that. The remote control, I went through this earlier. You press the button here. This black bit here will make contact. It could be a conductor that will either, or it's maybe a conductor or a resistance force. I don't know how it works. If it measures the resistance, I don't know. But it could close this circuit, which will set the appropriate signal down to the microprocessor here, a small chip, which will then, I think, encode that signal to be transmitted via infrared radiation, which will be emitted from this emitter here. That will be picked up with the receiver, the infrared receiver. Now next, I can't remember where I am now. Right, so I've covered that, I've covered that, I've covered that, I've covered those, I've covered that, I've covered this, I've covered that, I've covered that. I think I've got to just show you the main board. So this will be the main circuit board, I believe. It's got quite a few microprocessors on the back. 1, 2, 3, 4, 5, 6 of them. Maybe zoom into it and show you the numbers on them if it means anything. The light one first of all. Samsung. Oh. The light's just causing the reflection, it's making it hard to... That might be better. there's this yucky stuff on it as well. I don't know what the hell that's about, but it shouldn't be there, I wouldn't have thought. Super chip. So anyway, that's, and there's this one in the middle as well, I forgot, nearly forgot. See if I can magnify it. Maybe I should have done that in the first place. So enough on that, I'll show you the other side now. So I could only assume this will be the main circuit board that will control everything. Now I'm trying to find where the amplifier circuitry is. There's got to be an amplifier. So I think this is the heat sink here, this silver bit. Now I wonder if that's the... I could maybe just see a chip under there, circuit board under there. Let's see if we could zoom it in for you. You can see the legs on it at the bottom. I could just break it off in fact, see if I reel it any further. What I've done is I've got a pair of needle nose pliers and I just wrenched it off and I've kind of snapped it in two, but there is actually some sort of transistor like microprocessor. That may have been responsible for the amplification. I did have this sort of metallic, this heat sink on it, so I could only assume that's what that would be for. There's like a heat paste there as well, white heat paste on it, so there's not much of an amplifier. I don't know how powerful it was, but it couldn't have been that bad if it was a hi-fi. But usually amplifiers have a lot of heat sinks, and I didn't see very many of them on this. So I could only... Going back to this now, I wonder if... I don't think that could be anything to do with the amplifier. There is a heat sink on there, but this capacitor's acting as a suppressor. Now these diodes with that heat sink, that might... I don't know if that's the power side of things for the amplifier or not, as well as being a suppressor for the mains, because the mains transformer goes in there, so there's also these other little diodes. Easier if I zoom in on that. But either or, you could tell me in the comments what that is, but you've saw it anyway, so I've showed the guts of this. I've pretty much done the summary as well, so I'm just going to round the video off now. I'm going to have to tidy all this up. So I've just looked at the time and horrified, and I should have been, I've got very little time, I've got to get going now, so that's it. I'm just going to round the video off now. So I've showed you inside it. I've covered everything I can do for now. So I'll just see what else I put on my channel. Okay, right, I'll catch you later on, okay? Take care, catch you later, bye, see you later.